Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about capacitive transducers. So it is an important type of transducer used in measurement and instrumentation systems. So capacitive transducers are widely used because of their high sensitivity, accuracy, and ability to measure very small physical changes. They are commonly found in displacement sensors, pressure sensors, touch screens, humidity sensors, and many industrial automation systems. So we will see about the working principle of the capacitive transducers, their different types, advantages, disadvantages, and applications. So what is a capacitive transducer? So it is a device that converts a physical quantity such as displacement, pressure, force, humidity, or liquid level into a corresponding change in the capacitance. So this capacitance change is then converted into an electrical signal that can be measured and analyzed. The operation of a capacitor, a transducer, is based on the principle of variable capacitance. So whenever there is a change in the area of overlap between the capacitor plates, the distance between the plates or the dielectric material placed between them, then the capacitance changes. So by measuring this change, the physical quantity can be accurately determined. So to understand the working of a capacitive transducer, we must first understand the factors that affect the capacitance. The capacitance of a parallel plate capacitor depends on three important parameters. The permittivity of the dielectric material, the area of overlap between the plates, and the distance between the plates. So if the dielectric material has higher permittivity, the capacitance increases. Similarly, increasing the overlapping area of the plates increases the capacitance. On the other hand, increasing the distance between the plates decreases the capacitance. So even very small change in any of these parameters can produce measurable electrical outputs. So this high sensitivity is the reason capacitive transducers are widely used in precision measurement applications. So the first type of capacitive transducer works by changing the overlapping area between the two capacitor plates. So in this arrangement, one plate moves relative to the other. So causing the overlapping area to increase or decrease. So since the capacitance is directly proportional to the area of overlap, any displacement results in a corresponding change in the capacitance. So this principle is commonly used for measuring the linear displacement. So as the object moves, the overlap changes continuously, producing an electrical output proportional to the displacement. So one of the major advantages of this method is that it provides a nearly linear relationship between displacement and capacitance, making measurements simpler and more accurate. So capacitive transducers can also be used to measure the angular displacement. So in this arrangement, one capacitor plate rotates with other fixed plate. As the angle of rotation changes, the overlapping area between the plates also changes. So this variation in overlap produces a change in the capacitance. So by measuring this capacitance change, the angular position of the rotating object can be determined accurately. Such transducers are commonly used in rotary position sensors, control systems, and industrial automation, where angular movement needs to be measured with high precision. So the second important type of the capacitive transducer operates by varying the distance between the capacitor plates. So in this design, one plate remains fixed while the other plate is movable and connected to the object whose displacement is to be measured. When the object moves, the spacing between the plates changes. Since the capacitance is inversely proportional to the distance between the plates, a decrease in distance causes an increase in the capacitance, while an increase in the distance causes decrease in the capacitance value. So this type of transducer is highly sensitive and is particularly useful for measuring very small displacements. However, the relationship between the capacitance and distance is nonlinear, which may require calibration or compensation techniques for accurate measurements. Another method of achieving the capacitance variation is by changing the dielectric material between the capacitor plates. So in this type of transducer, the dielectric material moves between the plates or its properties changes. Since capacitance depends directly on the permittivity of the dielectric material, any variation in the permittivity results in the change in the capacitance. By measuring this change, the displacement or movement of the dielectric material can be determined. So this principle is commonly used in level measurement systems, humidity sensors, and displacement measurement applications where dielectric properties vary with environmental conditions. Uh, so let us see the advantages and the disadvantages of capacitive transducers. Capacitive transducers offer several advantages. They are highly sensitive and capable of detecting extremely small physical changes. They provide good frequency response, making them suitable for dynamic measurements. And they have high input impedance, which minimizes the loading effects on the measured systems. They also require very low output power and are suitable for small scale measurement applications. However, capacitive transducers also have certain limitations. The metallic components require proper insulation to ensure accurate operation. They are sensitive to stray electric and magnetic fields, which can affect the measurement accuracy. Nonlinear behavior may occur to edge effects, although this can be reduced by using guard rings. Additionally, the connecting cables can introduce errors because they add unwanted capacitance to the system. Capacitive transducers are widely used in various engineering and industrial applications. They are used for displacement measurement and position sensing in automatic systems. They form the basis of modern touchscreen technology, enabling responsive and accurate touch detection. In medical applications, they are used in pressure sensing devices such as blood pressure monitoring systems. They are also employed in humidity measurement instruments and liquid level detection systems. Proximity sensors use capacitive principles to detect the presence of a nearby object without physical contact. In audio applications, capacitive transducers are used in condenser microphones to produce high quality sound signals. These diverse applications highlight the versatility and importance of capacitive transducers in modern technology. So let us summarize what we have seen today. A capacitive transducer is a device that converts the physical quantities into electrical signals through the changes in the capacitance. So the capacitance can be varied by changing the overlapping area of the plates, distance between the plates, or the dielectric material between them. Capacitive transducers are highly sensitive, require low power, and provide excellent performance in many measurement applications. So despite certain limitations, the advantages make them one of the most widely used transducers in industrial, medical, and consumer electronics systems. Thank you for watching this video.